Hello everyone, welcome back to our YouTube channel. This is Mpumalanga Mathematics and Physical Science YouTube channel, and we are looking at Mpumalanga September 2016 trial paper 1 for mathematics for grade 12s. And in this session we're going to be looking at question 2, which is sequences and series. And this question is lovely because it contains almost everything. It's like a summary of everything that you do in sequences and series, so it covers mostly all the aspects. Looking first at question 2.1, the first 4 terms of a quadratic sequence are 1, -5, -13, -23. They say calculate the general term of the sequence in 2.1.1, and then which term has the value of -643. We are going to start off by 2.1. Not the right pen. (2.1.1). We have 1, -5, -13, and -23. We're looking at a quadratic sequence, and a quadratic sequence has 2 sets of differences, whereby the first difference is a set of a linear, and then the second difference is a difference that comes from a linear sequence. So the first here, we're going to say -5 minus 1, you get a -6, and -13 minus -5, you get a -8. -23 minus a -13, we get a -10. And you can see that the first difference is linear, and the first difference has a second difference, which is a constant difference. Now, -8 minus -6 is more like saying +6 minus 8. So you get a -2. Same with -10 minus -8, you get a -2. So we are not done. We have just found the differences. Now the differences lead us into getting the terms of a quadratic sequence. So 2a is equal to the first term of the second difference, which is -2. Now if we divide both sides by 2, we get that a is equal to -1. Then the second one for the first difference is 3a plus b is equal to -6. So 3 times -1 plus b is equal to -6. So a -3 plus b is equal to -6. b is equal to -6 plus 3, which is equal to -3. Next up, a plus b plus c is equals to the first term of the sequence, which is 1. Now we have a, which is -1, and b, which is -3, plus c is equal to a 1. So -4 plus c is equal to +1, and c is equals to 1 plus 4, which is equal to a 5. Now the nth term, or the general term, is given by an squared plus bn plus c, which is quadratic for a quadratic sequence. Then we substitute every term, which is -n squared minus 3n plus 5. Then we go back to the question. It says which term has a value of -643. Now 2.1.2. Which term, Tn, which term number what has a value of negative 643? But we have just given Tn a name in the above, that Tn can be given by negative n squared minus 3n plus 5, which means now that Tn is negative 643 is equal to negative n squared minus 3n plus 5. We can then see that this is a simple quadratic equation, and if we simplify this, we can see that n squared, if we jump or transpose to the left hand side, n squared plus 3n minus 5 minus 643 is equal to a 0. So n squared plus 3n minus 649 or 648 and 649, 648 is equal to a 0. Then we can factorize this by looking at the factors of 648. Now factors of 648 are 24 and 27, and these are the ones that can give you a 3. So how can you get a positive 3? If only the negative value is larger and the positive value is smaller, meaning this will be n 24, 27, and oh, I made a mistake here. If the smaller value is negative and the larger value is positive, so smaller value must be negative and the larger value must be positive, so that you can say 27n minus 24n. And that being said, we apply the zero law, which says n minus 24 is equal to a 0, or n plus 27 is equal to a 0, and therefore n is equal to 24, or n is equal to negative 27. But we don't have negative 27 terms, so therefore we're going to go with the positive one. So therefore term 24 has a value of negative 643. Next up, we have a set 2k plus 1 and 3k and 5k minus 5, which are the first three terms of an arithmetic sequence. Calculate the value of k and then write down this sequence in sigma notation for the first 20 terms. Here's what you can do. In 2.2, you have 2k plus 1 with 3k and 5k minus 5, which is arithmetic and it has just a common difference. So this is just 3k minus 2k plus 1, and also this is 5k minus 5 minus 3k. So you'll notice that I put brackets in because we're subtracting the whole term here with t2. So this gives us a 3k minus 2k minus 1, which is equal to k minus 1, and that is our common difference. And then in here we have 5k minus 5 minus 3k, which is equals to 2k minus 5. Now, since this is arithmetic and this is a common difference, this means that k minus 1 is equal to 2k minus 5. And to simplify, we can just take the 5 to the other side and the k to the other side. Well, 5 to the left side, k to the right side, so that the negative 5 becomes a positive 5 minus 1, and this is a 2k minus k, such that 4 is equal to k, and that is the value of k. When they say write down the sequence in sigma notation, that is for question 2.2.2, write down the sequence in sigma notation for the first 20 times. First 20 times, 2.2.2. We first need to determine what is this sequence. So we found that k is 4. So it was 2k plus 1. So now we say 2 times 4 plus 1 is 2. 3 times 4 is 2. 5 times 4 minus 5. And this gives us a sequence that is 2 times 4 is 8, plus 1 is 9 is 2. 3 times 4 is 12. 5 times 4 is 20, minus 5 is 15. So, for an arithmetic sequence, we can see that the common difference is 3. And formula for an arithmetic or general term is given by Tn is equals to a plus n minus 1d. So Tn is equals to the first term, which is 9 plus n minus 1 times 3. So the first term, Tn is equal to 9 plus 3n minus 3. And this gives us a value of Tn is equals to 3n plus 6. Now, we want to write a sigma notation, which will have Tn and the last value k starting at a certain position in this format. Now, we are going to finish at the first 20 terms, starting from when n is equal to 1 for this nth term of 3n plus 6. Now it is vital to put in the brackets. This shows that this is a sum of all the terms mentioned for 3n plus 6. Okay. Next up, 2.3, we're given a geometric series, which is 8x squared plus 4x cubed plus 2x to the power 4 plus ... And then it asks, for what values of x will the series converge? For which values of x will the series converge? 2.3.1. First, we have this 8x squared, 4x cubed, 2x to the power 4 plus all the way through. So it's geometry. We're looking for r is equals to t2 over t1, whereby this is 4x cubed over 8x squared. And this will give you a half x. And we have to double confirm this r value, which is taking t3 over t1, t3 over t2, which is 2x to the power 4 over 4x to the power of 3, which is equal to 1 over 2x. Next up, we see that the r value here, or the ratio, common ratio, constant ratio, is 1 over 2x. To check if something is converging, you must align with -1 less than r less than 1. So -1 less than 1 over 2x less than 1. We are looking for the values of x, which the series will converge, not the values of half x. So we have to multiply throughout by a 2, by a 2, and by a 2, such that we're going to get a -2 less than x less than 2. So the values of x in which the series will converge are in between -2 and +2. Next question is calculate the values of x if sum to infinity is equal to 8/3. Values of x if sum to infinity is 8/3. That is 2.3.2. The sum to infinity is equal to a over 1 minus r. Now the sum to infinity has been given, I know my infinity looks like an 8. So sum to infinity is equal to 8/3. So 8/3 is equal to 8x squared, that was our first term, over 1 minus half of x. Then we can simply cross multiply here. And when we cross multiply, we get that this is 8 times 1 is 8, and 8 times negative half of x is a negative 4x, which is equal to 8 times 3. 8x squared times 3, we get 24x squared. Then this looks now more like a quadratic equation, and we have to simplify it. We can take everything from the left hand side to the right hand side, such that we will be left with 0 is equal to 24x squared plus 4x minus 8. Then we can divide throughout by a 4. Divide throughout by a 4, 4, 4. So 0 is equal to 24 divided by 4 will be a 6. X squared plus x minus 2. And this can be factorized into 0 is equals to, opening two bracket, 6x with x, and then the factors of 2 that can give you 1 is just 1 and 2. So if we check the factors, that will be 1 and no, we can put 6x and x. It will not give us a total, so sorry about that. The factors in here would be 3x times 2x, 3x times 2x, which gives us 6x, and then a 2 here and a 1 here, and this one will be positive and this one will be negative. So 3x squared, 3x plus 2 is equals to a 0, or 2x minus 1 is equal to a 0. Then we find that 3x is equal to a negative 2. Then we divide by 3, and x is equal to negative 2 over 3. Then 2x is equal to positive 1 divided by 2, and x is equal to 1 over 2. Then we have found the values of x if the sum to infinity is equal to 8/3. The last question is a little bit tricky. It says the first, third, and 13th terms of arithmetic sequence, the first three terms of a geometric sequence. So if the first term of both sequences is 1, determine in 2.4.1 the first three terms of the geometric sequence if r is greater than 1, and then in 2.4.2 the sum of 7 terms of the geometric sequence if the sequence is 1, 5, 25. Right. the first term, let's look for arithmetic. T1 is equal to a plus 1 minus 1 d, no, not a plus, a minus a, yes, it's a plus n minus 1 d plus, we'll just substituted that to a 1 minus 1, which is equal to a 1, and this is the same as T1 of the geometric, which is equal to a r to the power of 1 minus 1, which just gives us a and has been given the value of 1. Now, term 3, which is given by a plus 3 minus 1 d, is the same as term 2 of the geometric, which is ar to the power of 2 minus 1, which is just ar, and term 13 is given by a plus 13 minus 1 d, and is given by T3, always the same as T3, which is ar to the power of 3 minus 1, which is equal to ar squared. Now, if we simplify the arithmetic part, term 1 is 1, term 3 is, now that we know that a is 1, term 3 is just 1 plus 2d, and then term 13 will be equal to 1 plus 12d, and we check the geometric that T1 is 1, T2 is just whereby a is 1, so it's no longer ar, it's just going to be r, and then T3 is going to be r squared. We have said that T3 goes with this one, T13 goes with this one, T1 goes with this one. This is arithmetic, this is geometric. So this means T3 of arithmetic is equals to T2 of geometric. Let's start with that. 1 plus 2d is equal to r, and also 1 plus 12d is equal to r squared. So this looks like equation 1, equation 2, substitute equation 1 in equation 2. And if we do that, we get 1 plus 12d is equal to 1 plus 2d squared. 1 plus 12d is equal to 1 plus 2d times 1 plus 2d, and 1 plus 12d is equals to 1 plus 2d plus 2d plus 4d squared. 1 plus 12d is equals to 1 plus 4d plus 4d squared. Then we can put everything into one side such that we're going to have 0 is equals to 4d squared plus 4d minus 12d plus 1 minus 1, such that this is 0 is equals to 4d squared minus 8d. And then we can simply divide by 4, divide by 4, divide by 4, and we get that 0 is equals to d squared minus 2d, and 0 is equals to, we factor out d, we are left with d minus 2. D is equals to 0, or d minus 2 is equals to 0. And then lastly, this means that d is equals to a 2. And therefore, the first three terms are going to be what? Term 1 will be 1, and then term 2 will just be what? Term 2 will be 5, since if we look at r is said to be equal to what? 1 plus 2d, which is 1 plus 2 times 2, which is 1 plus 4, which is equals to a 5. So term 2 will be 5, and then term 3 will be equal to r squared, so it's just 5 squared, which is 25. And those are the first three terms if r is greater than 1. And you can see r is greater than 1 because r is equal to 5 divided by 1, which is equals to a 5. Lastly, the last question says the sum of the 7 terms if the geometric sequence is 1, 5, and 25. (2.4.2). Now that is 1, 5, 25. R is equals to 5. For Sn is equals to, where r is greater than 1, we use Sn is equals to a r to the power of n minus 1 over r minus 1. This is equal to 1, and then our r value is 5 to the power of 7. So S7 minus 1 over 5 minus 1. And then we find that S7 is a 19,531. Thank you for watching, and please like, share, subscribe, and we'll see you in the next video.